I'm not sure what happened there. I have a feeling I didn't record what I just went over. So let's try that again. Shingolipids. And if I'm repeating it, then I'm not going to be very happy. Basically, these are phospholipids that are built on a sphingosine backbone. And sphingosine is an 18-carbon amino alcohol. So the business end of this, I'm going to start with, contains 2 hydroxyl groups and the amino group. And then we have a carbon-carbon double bond that is trans. And then we have 13 more carbons in that hydrocarbon chain. That should be 18. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay, got 18 carbons there. 13 carbons after that double bond. Okay. So there are many derivatives of these sphingolipids, essentially. One of them is a ceramide, which has a sphingosine backbone. With a fatty acid joined by an amide linkage. So its linkage is through that amino group. Okay. So this is the site of fatty acid attachments. If we have sugars attached, they will attach through those hydroxyl groups. Okay. So we're going to look at the reaction here that occurs when a ceramide is formed. Again, here's that business end of the sphingosine molecule. You should be able to draw a sphingosine, and you should understand, and I'm just going to put an R here for that. Whoops, R for that alkyl chain. And we're just going to represent our fatty acid like this. Carboxyl group, of course, is the business end of that molecule. And then we get that amide linkage. Just like we saw in the polymerization of amino acids. So we have our nitrogen, and then we have our carbonyl group and our chain. So again, that amide linkage that joins that fatty acid to the sphingosine backbone. So I just want to point out that, whoops, let me put that back up here for just a second. These ceramides are found in plasma membranes, and they are involved in transmembrane signaling, and we might see them appearing in rafts of those lipid bilayers. Okay. So the last group we're going to look at with respect to lipids are the glycophospholipids. So glyco, which tells me I've got some kind of sugar attached. So glycophospholipids, lipids. Oh, I can't spell today, sorry. So these are composed of a ceramide and one or more sugar or carbohydrates, sugar residues that are linked by a glycosidic bond. Okay. And this is at the 1-hydroxyl group. In that business end of the sphingosine backbone. Okay. And one of those is called a cerebroside. Okay. And this one either has a single glucose or a single galactose. Okay. And so that would look like, again, I'm just going to shorten the structure by representing that alkyl group in that manner. So again, we still have that fatty acid attachment here because we're starting with the ceramide. And it's through that hydroxyl group on carbon 1 that will have that the sugar attachment. And in this case, it's beta galactose. I hope I left myself enough room here. I might have to make this kind of smaller than I normally would. There we go. And here's our galactose attachment. And up and up. And this is a beta galactose. That is attached to that ceramide. There's one other I'm just going to mention. We're not going to draw these, but ganglioside is a more complex glycosphingolipid. Not enough room. And this has a ceramide backbone as well. But has 3 or more esterified sugars. Or carbohydrates attached to it. And this is very important in nerve impulse transmission. And that's it for the drawing and this particular discussion of lipids. So